variable. I'll call it a and I'll set it equal to 5. It's just going to be an integer. If I want to create a reference to that variable, I can do so by typing in the type of the variable, followed by an ampersand. Note here that the ampersand is actually part of the variable declaration. In the previous video about pointers, we learned that if we create a pointer, we can use the ampersand operator here to actually take the memory address of an existing variable. It's different here because the ampersand is actually part of the type. It's not, you can see it's not actually next to an existing variable. It's part of the type, so just note that difference. Because with a lot of people, as soon as you see an ampersand, they think, oh, it's a reference, or oh, it's definitely an address of. It's kind of depending on context here. So in this case, because it's next to the type, it's a reference. So if we keep writing this, I'll call this ref and I'll set this equal to a, and that's really all you have to do. There's no kind of weird operator or something that we have to use here. Is we can use ref as if it was a. So if we set ref now equal to 2 and then print a, if we run our program here, you're going to see that a is equal to 2 now because we're printing a. Suppose that we wanted to write a function which was supposed to increment an integer. If we just write the function like this and then do something like value plus plus, what will actually happen is if I create my integer over here, and then I call increment with a as the parameter, what's going to happen here is since we are just passing this by value, you can see that we're not passing this as a pointer or as a reference or anything like that. It's actually going to copy this value 5 into this function. Just copy it. It's going to create a brand new variable called value with that. So it's almost as if we were to write something like that. That's exactly what will happen. So instead of that, and I can prove it of course if I just run my code here, and we log this, we're actually going to still end up with 5 printing to the console, which you can see over here. What I need to do is I actually need to pass this variable by reference in order for it to increment, because what I really want to do is I want to actually affect this variable here. So how can I achieve that? How can I actually modify this variable by passing it? Because I'll modify this to actually take in a pointer, and I'll still call it value. And then what I'll do here in increment is I'll pass the memory address of a. Instead of just the value 5, it's now passing the memory address of this variable. One more thing I'll have to do is actually dereference this value so that we can actually write to that memory instead of modifying the pointer itself. If I just do this without the dereference, it's going to just increment that address, right? So pointer, of course, just a memory address, just an integer. And if I do value plus plus without the asterisk, without the dereference operator, then it is just going to increment my memory address, not the actual value there. Now, because of the order of operations, it's actually going to do the increment first and then dereference. So what I want to do instead is dereference first and then increment, because I don't want to increment the pointer and then dereference it. I want to dereference the pointer first and then increment the value at the pointer. So if I compile this code and run it, you will see that I will get the value 6 printing. So awesome, we've successfully do is rewrite this to take in a reference instead of a pointer. And then what that means is that I lose this whole need of dereferencing. I can change this back to exactly what it was. And then over here, I don't need to pass the memory address of a, I can just pass in a. And since it is being passed by reference, we've basically rewritten the code to do exactly the same thing. Internally, when it gets by that is that suppose that I had 2 integers. I had a and b was set to 8, a was set to 5. And then what I wanted to do is declare a reference that was set to a, and then maybe later on in my code, I decided, oh, actually, you know what? I want to set my reference to be referencing b. Can I do something like that? The answer is no, you can't do that. What will happen in this case is that it will effectively create a reference to a, and then when you decide to set that reference equal to b, it will just set a equal to the value of b, which is 8. So what you will end up with here is a being equal to 8 and b being equal to 8. And of course, because of that, that also means that when you declare a reference, you need to actually assign it to something. You cannot just do this. You can see that the compiler will not let you do that. It requires, and in this example specifically, what would I do if I actually wanted this kind of functionality? If I wanted to actually change what ref was a reference of? Well, of course, as I mentioned earlier, this isn't a real variable. We would need to create some kind of variable of sorts that we could set up to point to a first, and then later on we could switch it to point to b. Instead of this, let's just make this a pointer. We can initially set it to the memory address of a, and then when I wanted to switch to it being pointing to b, I can just switch it like this. Because remember, to actually start affecting the value that this pointer is pointing to, I need to dereference the pointer first and then set it equal to something like this. So in this case, I'm setting a equal to 2, and in this case, I'm setting b equal to 1. And if I was to log both of these, they should be 2 and 1. And you can see that they are.